Picture this. You board a private jet in Singapore at 9 p.m. 16 hours later, you step off in San Francisco without a single fuel stop. No connections, no technical stops. Just 7,340 nautical miles of uninterrupted flight across the Pacific Ocean. This isn't theoretical. It's what the Gulfstream G700 does routinely. And it's rewriting the entire playbook for ultra-long-range business aviation. When Gulfstream announced the G700's maximum range of 7,750 nautical miles, the number seemed almost academic. After all, the Bombardier Global 7500 advertises 7,700 nautical miles. That's only a 50 nautical mile difference on paper. But here's what the spec sheets don't tell you. Maximum range figures are calculated under ideal conditions with minimal payload and reserves. The real story isn't about flying empty from point A to point B. It's about maintaining usable range, with 8 passengers, full catering, baggage, and enough fuel reserves to divert to alternates hundreds of miles away. That 50-mile advantage translates into entirely different route capabilities. The G700 can connect Singapore to San Francisco, London to Perth, or New York to Dubai, with operational margins its competitors simply can't match. Let's examine one of the most challenging routes in business aviation: Singapore to San Francisco. Distance: 7,340 nautical miles. Flight time: approximately 14 hours and 30 minutes. The G700 carries 48,200 pounds of Jet A fuel. At Mach 0.85 cruise, the Rolls-Royce Pearl 700 engines consume roughly 4,860 pounds per hour combined. Do the math. You need about 70,470 pounds just for cruise. But regulations don't let you depart with only cruise fuel. You need enough to reach your destination, then fly to an alternate airport, plus 45 minutes of reserve. If San Francisco has coastal fog, and San Jose is your alternate, that's another 6,075 pounds of fuel needed. The problem? You need roughly 76,545 pounds of fuel for this mission. That's 158% of the G700's maximum fuel capacity. This is where engineering brilliance shows up. The G700 doesn't just carry fuel efficiently, it manages weight across every system to maximize usable payload. The carbon fiber wing structure alone saves roughly 2,200 pounds compared to aluminum construction. Those 2,200 pounds translate directly into payload capacity. With 8 passengers, crew, baggage and catering, this mission operates at approximately 99,600 pounds takeoff weight, just under the G700's maximum of 107,600 pounds. Halfway across the Pacific, 1,200 miles northeast of Midway Atoll, weather forecasts for San Francisco deteriorate. The marine layer is thicker than predicted. Arrival conditions now call for an instrument approach to minimums. This is where range becomes operational flexibility. Most business jets operating at the edge of their performance envelope would be forced to divert. But the G700's fuel reserves provide options. The flight continues to San Francisco. After 14 hours and 47 minutes, the G700 lands with 4,200 pounds of fuel remaining, well above reserve minimums. A Global 7500 flying the same route would land with approximately 2,800 pounds, barely above regulatory minimum. That 1,400-pound difference might seem academic, until weather forces a missed approach and a go-around burns an additional 800 pounds of fuel. How does the G700 actually achieve this performance? 5 interconnected systems, each optimized to squeeze every nautical mile from each gallon of fuel. Pearl 700 engines. These produce 18,250 pounds of thrust each, but the innovation is efficiency. The blended Blisk design, where fan blades and disc are machined from a single piece of titanium, improves efficiency by 3% compared to previous generation engines. That's 145 nautical miles of additional range. Active control side sticks. Unlike passive joysticks, These provide force feedback based on aerodynamic loads. Maintaining optimal angle of attack within 0.5 degrees throughout cruise reduces drag by 2%. Over 7,300 nautical miles, that saves roughly 1,400 pounds of fuel. Adaptive wing system. Trailing edge flaperons deploy in micro increments during cruise, optimizing camber for current conditions. The wing's aspect ratio of 8.2:1 reduces induced drag by approximately 8% compared to traditional business jets. Advanced environmental control. Enhanced heat exchangers recover 15% more energy from exhaust air, reducing bleed air extraction by 200 pounds per hour. That translates to 80 pounds of fuel saved on ultra-long missions. Predictive avionics. The Honeywell Symmetry flight deck continuously calculates optimal cruise altitude and speed. On the Singapore-San Francisco route, the system recommends step climbs at precise intervals to maintain optimal lift-to-drag ratio as the aircraft burns fuel and becomes lighter. These systems don't operate independently. They're integrated into a comprehensive performance package, where improvements in one system enable optimizations in others. In the charter market, the G700 can offer non-stop service on approximately 127 city pairs that no competing ultra-long-range business jet can reliably serve, with typical passenger loads. These aren't obscure routes, they're high-demand connections like Tokyo to New York, Dubai to Los Angeles, Perth to London, and Sao Paulo to Dubai. Take Perth to London. 7,660 nautical miles. Commercial passengers face minimum 20-hour journeys with connections. The G700 completes this in 16.5 hours non-stop. A mining executive can depart Perth at 10 p.m., arrive London at 6 a.m., conduct a board meeting, fresh from sleeping in the master suite, then return that evening. Ultra-long-range capability commands premium pricing of 25 to 35% above standard transcontinental rates. Customers aren't paying extra for luxury. They're paying for route capability that eliminates connections and compresses travel time. The excess range capacity also translates into reduced maintenance costs. Operating within comfortable performance margins means lower engine temperatures, fewer pressurization cycles, and less thermal stress on avionics. Gulfstream publishes the G700's maintenance costs at approximately $1,847 per flight hour, 12% lower than the Global 7500's $2,105 per flight hour. Rolls-Royce's UltraFan technology promises 25% improvement in fuel efficiency. If that scales to business aviation, a future G700 could achieve ranges approaching 9,000 nautical miles, opening routes like Sydney to Los Angeles and Sao Paulo to Tokyo. Sustainable aviation fuel offers up to 80% carbon emissions reductions while maintaining current capabilities. The G700 is already certified for 50% SAF blends. Electric propulsion remains years away for long-range aviation, but battery improvements of 5 to 8% annually mean short-haul business aviation could go electric by the mid-2030s. The Gulfstream G700 7,750 nautical mile range isn't just a number on a spec sheet. It's the culmination of integrated engineering that delivers route capabilities fundamentally changing ultra-long-range business aviation. From Singapore to San Francisco, the G700 demonstrates that range changes everything. It's not about flying farther for its own sake. It's about eliminating connections, maintaining reserves for weather diversions, reducing maintenance costs through operational margins, and serving routes competitors simply can't reach. For now, the G700 stands as the benchmark, the aircraft that redefined what's possible when you need to connect any two cities on Earth, non-stop, in absolute comfort.